Do you remember which function prime is 1 over x? So always remember, when we write a dx over x, this is the same thing with 1 over x times dx. They are the same, different mode of presentation. So which function we differentiate to get 1 over x? What should I write here? And based on that, then I will plug in e to the third, e to the fifth first, and then minus when I plug in e to the third. But we have to remember which function we differentiate to get 1 over x.
Natural log.
Excellent. Yes, but don't forget the absolute value. Awesome. Yes. So then I plug in e to the fifth, and now I can drop the, but initially I have to put it in. Natural log of e to the fifth minus natural log of e to the third. Anyone remembers a property of natural log when natural log or log is applied to a power? How do I simplify this? There is a property of the log that allows us to simplify log of e to the fifth power. How? How do we do that? Anyone remembers the property? The power goes in front as a factor. So we have 5 times natural log e. Anyone remembers how much is natural log e?
One.
Thank you very much. So then minus 3, which is 2. So I don't want you to fully rely on the calculator ever. I'm just curious now, because we have this feature. You can use it to check. So it goes from e to the third to e to the fifth. I was not able, and I can go back in time here, and you will see we were not able to get the correct answer out of this. So the calculator has a lot of flaws. So let's see, maybe this time it will calculate, but I'll show you an example in which you... So when I click enter, I should get the answer too. Let's see what happens. Okay, now, when I go back, because it still should be there, I can show you a similar problem where the calculator was not able. Here it is. Okay, so from e to the 49, which is very similar to what we just did, but it's a different function. And when I press enter, it will not be able to give us the correct answer. You'll see what happens, because this power is too big for the calculator. If I increase this to 55, I will probably not be able to get a correct answer. So when you click enter, we did this with my STEM class, and it took forever and ever and ever, and it says I can't do it in a very elegant way. It's not going to say I can't do it, but it will say it reached the tolerance limit, result is not returned. So my point is, it's not an error at all. It's a very simple answer, but the calculator could not do it. So again, with the previous one, I probably have to enter it again. So if I change, we don't have to do this, but I'm just showing you because I don't want you to think. So if I put 55, it will be 55 minus 3, and the answer will be 52. I didn't mean that. I meant e to the third and e to the 55th power. Maybe because the function is simpler than the one that you just saw from the other class. Maybe it will work, potentially. X to negative 1 is 1 over x. So it may give us the correct answer. Ah, it's thinking and thinking and thinking, and yes. So there are limits. So the calculator cannot do it. Although the answer is very simple. It's going to be 55 minus 3, which is 52. And it cannot do it because this is too large of a number for the calculator. Okay, enough of that. The point I'm making is be careful. Okay, so let's look at number 11. In number 11, we have, they're asking us to find the integral from 0 to 5 from g of x dx. And g of x is given to us as x squared for x less than or equal to 2, and 6 minus x for x greater than 2. We had a similar problem last time when we reviewed for test 3. How do I determine this integral? Anyone would like to give us an idea?
Set them equal to each other.
No, this is not the consumer surplus and producer surplus. No. So this says find the integral from 0 to 5, and g of x is given in 2 pieces. So it has to be a sum of 2 integrals. 0 to 5 includes 2, so somewhere in the middle we have that 2, right? From 0 to 2, it has to be one integral, with dx, of course. And from 2 to 5, it has to be from a different function, of course, with dx. Which function do I put here, and which function do I put here? That's all there is to it.
X squared first.
Yes, because it's less than or equal to 2, of course. And of course, the other one is greater than 2, which means from 2 to 5, so we have 6 minus x. Exactly. So in order to finish this up, I have x cubed over 3 from 0 to 2 plus 6x minus x squared over 2 from 2 to 5. And I plug in the numbers. Any questions on this? Do you want me to finish it up, or is that okay? You tell me. Yes, no? Okay. So let's also look at 9. And that's my page 11. And the 9 we have 0 to 1 from e to negative 2x dx. Also remember one very important piece of information or important condition. So whenever we calculate a definite integral, this function has to be continuous on this. When is 1 over x not continuous? At what value of x 1 over x is not continuous? When x is when x is
0.
yes, but 0 is not here, so it's safe. From 0 to 5, these are polynomial functions. Both are safe. This is continuous on 0 to, this is continuous on 2 to 5. They're continuous everywhere. So now also here, I know that this function is continuous everywhere. So we are all safe from 0 to 1 furthermore. Okay, so now I need to find a function whose derivative is this, and then plug in 1 and subtract when I plug in 0. So which function prime is this? We discussed this situation before. See if you remember it. Anyone remembers which function we differentiate to get this?
Is it just going to be that over 2?
So e to negative 2x over negative 2. Correct.
Oh, yeah.
Correct. So always remember, leave the constant outside. Plug in 1, e to negative 2, minus when I plug in 0. But e to 0 is?
1.
Thank you very much. And that's it. You can rearrange it if you'd like. Negative 1/2. This is 1 over e squared minus 1. You can just distribute the negative and nothing else, and you have 1 minus 1 over e squared if you'd like, but this is fine, this is fine, this is fine. So in general, when we integrate e to nx dx, we have e to nx divided by n plus a constant c. So if this is negative 2, then I have negative 2 here. If this is 5, then I have 5 here. Of course here as well, but if this is 10, then I have 10. Same thing. I send you an email today kindly asking you to fill out this survey. It's very important. My boss looks at it. So, and I also give you an incentive. So it will only take you a couple of minutes, and I give 5 points, bonus points on the final exam. If you upload just the last page that says, thank you for completing the survey. This is a new system. This is the first semester we are using this new system. I don't know exactly how it looks like, but it's in the assignment. So if you can, I kindly ask you to do it if it's possible. In the past, we had them on paper and we were in class and students would fill them out. So now, I know it's another survey, I know, but if you can, as I said, it would be great. On Thursday, we're going to continue with all the others that we haven't gotten to today. More partial derivatives, finding max min for those functions, anything else that you would like to work on. And that will be our last class. So I will see you on Thursday. But please stay if you have